What is the relationship between the two triangles? Are they congruent? That's a good question. What is the relationship will tell us. Now remember, I only have two of them memorized, and that's angle, 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 and side, side angle. If I see either of those two relationships, I cannot guarantee congruence. So if I see either of those, then I will say that it is not congruent. But what I notice on these two is I've got this angle mark and this angle mark, so those angles are congruent. Then we got this one and this one, so they match in both triangles. And then the 3 marks and 3 marks. So what I have here is an angle, angle, angle relationship for both triangles. And angle, angle, angle is one of those that we cannot guarantee is congruent. So are they congruent? We say no. Really just means we can't guarantee that they're congruent, but this is fine. Here's our objective. I can translate and reflect points and lines on a graph. Really, we're just going to be focusing on the points. So take 30 seconds, copy this down, then we'll get started. So quick note about the objective. Translate just means you're going to move it, some kind of figure on a graph. Sometimes it's not on a graph, sometimes it's just a point. And then reflect really just means that we're going to mirror some kind of object or image, something that's on some kind of graph. Now, as usual with math, we have a little bit of vocabulary. Why do they use this vocabulary? I don't know. I didn't make it up. But the pre-image right here that they're talking about, the pre-image is kind of the figure that you start with right there. So it's the figure that you start with. Now, after you do something to it, whether it is today a translation or a reflection, after you've done something to it, that is what we call the image, right? So that's why it's saying it's the figure before it has been moved. And again, moving means today, just moving it or mirroring or reflecting it. And then the image is what you get after it has been moved, okay? Now this marking right here is, in math, we call this a prime mark. And that just indicates that is going to help us to tell if a shape has been moved or if it is not. So for example, what they will do is they may start you with some kind of trapezoid, like this one. Okay, now this is the trapezoid that I start with, so we would call this a pre-image. And then if I were to take this pre-image, I'm just copying and pasting it, and let's say that I moved it. Okay, so let's say that I moved it maybe to the right and then maybe up, something like this. And yes, that is the movement for the shapes that we're going to be looking at. You're never going to take a shape and then move it diagonal like this, because mathematically it's easier to do this first left to right and then up and down, or vice versa. So this one I would say I moved it to the right and then I moved it up. Now, since this was my pre-image, this is no longer a pre-image. It's the pre-image that's been moved. So as it turns out, this is what we would call just the image. And that's what we're saying right there. You got a pre-image, then you got an image. And if we were to look at points on the corners of this trapezoid, let's start with the pre-image. So let's say that this was my point right there. And we'll just call it A. So this is point A on my pre-image. Now the corresponding point on the image right here, it would be called A prime. Okay, but again, even if I didn't label this one as pre-image and this one as image, I would know that this one has to be the image because the image is showing letters with the prime mark right there. And if it doesn't have a prime mark like this one, then I can know then that that is a pre-image. Now, if by chance you take an image and then you do something else to that one, you can have like a double prime mark to that as well. We shouldn't see that today, but just know that we probably will eventually, maybe. If not today, then maybe in 10th grade. You don't have to call them these things, but it's the vocabulary that I'm going to use to help us to get used to it, because we've seen this stuff actually already in 8th grade, and now you're going to see it in 9th grade, and next year you're going to see it in 10th grade. But they may do it in a more fun way. I don't really care. Translations is just moving stuff. So, move a figure, point, or object. Really, we're just going to focus on points, not really figures or objects. Now, moving points on a figure is going to help us to move a figure or an object. But again, our main focus here is the points. If we can just figure out how to move the points, then everything else will fall into place. This means we cannot rotate. There's no flipping the shape. We're not going to shrink it or make it bigger. In fact, shrinking or enlarging would make these not congruent. But since we're not doing either one of these, and we're just focused on moving the figure, which means it does not change orientation, that means that translations will maintain congruency. I'm going to put the congruence mark there. It's not my best one. That's okay. So if you translate a figure, meaning you're just going to move it, you haven't changed the size, and you've got the same shape, all the same side lengths, all the same angles, which means that you have a new shape, but it's a shape that is exactly the same as the original one. It's just moved. On the assignment, when it says map, it just means to move it, which could mean to transform it, which is what a translation is. So between today's lesson and next time's lesson, we're going to go over all the transformations, which is to translate, rotate. Today we're going over flipping as well. And then this would be called a dilation. That should bring up some stuff from 8th grade. But when it says map, that means we're going to just transform the shape in some way. Move it, flip it, rotate it, or make it bigger or smaller. So translations do not change size, so we already went over this. This is the congruence part right there. So yeah, we're just taking the shape and moving it. That's it. So the first way that they're going to want us to do this is to translate on a graph. So they're going to have both a pre-image and an image for us. And then we have to identify on the pre-image and the image corresponding points. And really only one set of corresponding points will do, because all the points on the shape are going to be moved exactly the same way. So once we can find corresponding points, then we can determine which is the pre-image or which is the image. And it doesn't matter if you switch these, by the way. But once we know which of the figures we start with, then we look at the one that's been moved, and we can see, well, how far left or right has it been moved, which will be important for us. We say how far left and right it's going to be moved, and then also how far up or down it will be moved. Because again, we can't say mathematically that we're going to move things diagonally, or at least if we did, it would really complicate things. So right and left, at least since we're looking at this usually on graphs, that would be for our x-axis, which is left and right. And then up or down, you can kind of look at the y-axis. Now, we don't really look at the axis either. But again, if you're confused, especially when they only give us an ordered pair, then you can think of which one is which. X-axis, y-axis, and then go from there. Just to help us remember when we see a graph like this, and yeah, the lines aren't very straight, but that's okay. The horizontal axis is the x-axis, and the vertical one is the y-axis, which we're going to need for flipping the stuff, the reflections. Okay, once you can figure out how far it's been moved, right or left, or up or down, then you can answer the question, how far it's been moved or translated. That's it. So please don't overcomplicate this, and just count. That's all we're doing, is counting how far left and right, how far up and down. So determine which translations would map figure H onto figure I. So just from the wording right there, I don't really need to look at the graph. And the graph didn't tell us, it didn't show us any prime marks either, so I can't really tell right here which one's the pre-image and which one's the image with just the graph. But this wording right here tells me which one is. We're going to take figure H and then map it or move it onto figure I, which means that figure H right there is going to be my pre-image, or it's the figure that I'm starting with. And then figure I is going to be the image. So if it helps, you can go in here and label the two, okay? Let me keep them as is. But I do know now, this is figure H, so this is where I'm starting, and this is where it's ending. Start, end. So I've got to take a point from this shape and then move it onto this shape right here. So, like I said before, we tend to focus on left and right first and then up and down, which is shown, this is the way it's going to look like in the assignment. These are drop-down menus, and then you fill in the blanks with how far they've been moved. So, on this, We don't need all the points. I'm going to do 2, but I'm going to show that it doesn't matter which one you choose, okay? Because when you move the shape, again, we're not changing the orientation, so it doesn't matter which point you choose. I choose this point, right there on the very far end of figure H to the right. Now its corresponding point on figure I, which is the image, would be right here. So how far has it been moved? Well, on the graph, it already has the grid lines for us to see how far they have been moved. Without the grid lines, it might be a little bit more difficult to tell. But first, I can see that this point has been moved to the right. And then from there, it's been moved down. Okay, now that's just part of the assignment. That means right now we know that we would choose this option in the first box, and then it's moved down, so we can check this option right here. But these boxes right next to these pull-down menus we're going to need to fill those in ourselves. So how far has it been moved? All we got to do is you can count boxes. So you can say 1, 2, 3 boxes, so that'd be to the right 3. Or if you want to count lines, you can count lines as well, 1, 2, 3. So this, again, it's just the point, but the whole figure as well has been moved to the right 3 units. And then from there it was moved down. Count boxes, count lines, doesn't matter. 1, 2, 3, 4, 5 boxes. Or you can count lines. 1, 2, 3, 4, 5 lines. So it was moved down 5 units, and now I've filled in this last box. Now that's enough. That's all we got to do to get full credit for this specific question. But I'm going to do this again just to show that it doesn't matter which point you choose. But I'm going to try to go to the extreme here. So in figure H, I would start with this top left point, and its corresponding point on figure I is right here. So from there, I can see I've got to go to the right, once again, and then from there, I would have to go down. But again, how far to the right would you go? Well, you can count boxes, you can count lines, it doesn't matter. Whichever one you choose, it's going to be to the right 3. And then down, of course, we can probably tell now, it's going to be down 1, 2, 3, 4, 5. 5 boxes, or 1, 2, 3, 4, 5 lines. And this would be true for all 1, 2, 3, 4, 5 points on the shape. But notice, when I've done this, and this is important too, because some students, they look at this and they're like, I don't know what the crap is happening with these slanted lines right here. Well, you don't have to know. You just got to focus on the points. Don't worry about the lines. And really, all we got to do is focus on one point if we know it's a translation. How do we know this is a translation? They said it is, right there. And translation just means we're moving the shape. That's it. But all the points. This one would be 3 to the right, 5 down. 3 to the right, 5 down. 3 to the right, 5 down. And again, if you want to switch those, let's say you want to go down 5 to the right 3, you're going to get the same exact image from the pre-image. So later on in this lesson, what they're going to do is they're just going to give us like the pre-image right here, and then they'll say translated 3 to the right and 5 down. Okay, well then you just count 3 to the right and then 5 down. We'll get there. What is the image point of 3, 7 after a translation? 4 units to the left and up 2 units. Okay, no problem. Well, we know that to the left, that is going to be, that's left and right, but just left for this one. That's my x-axis, which means left is for x-axis, which means that's going to affect our x value in this ordered pair 3, 7. On the other hand, the next part says that it's going to be up 2 units, and up and down is for the y-axis. So just so we can get a clear understanding of this, or hopefully, you have a vertical axis, which is your y-axis. You have a horizontal axis, which hopefully if it was drawn better would be horizontal. But that's pretty good for me. So the horizontal axis is pretty clearly left to right. So when it says left, it's part of our x values. And then up and down is clearly the y-axis. Okay? Now, you may not picture this all the time. Some of you may have enough experience with this not to need the picture right there. But if I were to put 3, 7 on the graph, this point, it would be, I'll say right there. So we can see just by doing this that this point would move to the left 4 and then up 2. Now, I don't really need a graph, but that would give me the image of the pre-image point 3, 7. But here's what happens without the graph. So if you were to take this ordered pair that we start with, 3, 7, which is our pre-image, and then we were to apply this set of movements for this pre-image. Left 4, up 2. Well, left is going to subtract. And why is it going to subtract? Because to the left on the x-axis makes it smaller. So the 3, all I need to really do is subtract 4. And whatever that result is going to be my x value for the image. So 3 minus 4 is going to be -1. Now that's my x value in the ordered pair for my image. Okay? And then the next part says it's going to move up. Well, up is in the positive direction, meaning that we're going to add to the y value. So we're going to add 2 units to the existing y value for the pre-image, which is 7. So I'm going to take 7, add 2. 7 plus 2 is 9. And we see it kind of works. I mean, my picture here isn't very proportional, but this would be about -1, 9, something like this. That right there, we just found it, is our image. So on the assignment, you want to write this, but I'm just trying to clarify the difference between a pre-image and an image. The pre-image is the values you start with, or the point that you start with, or shape. The image is the shape, the same shape or point, but after some kind of movement. Let's say, just theoretically on this one, if it had moved to the right 4 units, then I would have had to add, because to the right would be adding more to the x's. And then let's say this one said down, well, then I would have had to have subtracted, because going down on my y-axis will make this more or less. It would make it less, meaning subtract. On these problems, what they're going to do is they're going to give us a figure, and then they're going to tell us how much to translate it, which means, again, all we got to do is be able to count and then know which direction we're going in. So, just like we did before, you can pretty much ignore the lines. The lines have tended to confuse students, not just in 8th grade, but in 9th grade and then other grades. So don't worry about lines, just focus on corners or points that they give us. Because if you can do that, then it's a lot easier to count, but you have to kind of mentally erase the rest of the stuff that's on the graph. Once you know that you're just focusing only on the points, then you just got to read and see how far they tell you to move it, left or right, and then up or down. That's it. If you can count that much, then you can do that for all the points. Again, just the points, not the lines. Just focus on the points, and then once you get that new figure on the graph, which will then be your image, then you just got to connect the dots with the lines. It should be exactly the same shape that you start with from your pre-image. So translate the figure 2 units to the left and then 3 units up. No problem. But I've got to do it. I've got 4 points, right? There are lines. I just don't care about the lines. I will take care of the lines after I've moved the figure. But I have to move not the figure, but the points. I've got to move all the points. So it's saying up here that it's going to be 2 units to the left. And then after that, we're going to move the point, all 4 points, 3 units up. Okay, 2 units to the left, 3 units up. So, can we count? We should be able to. So I'm going to start with this point up here at the top. Okay, Well, it says move this 2 units to the left. Okay, so you can count lines, 1, 2, or you can count boxes, but it needs to go 2 units to the left. And then from there, it says 3 units up. So it's kind of like you're just taking this point and then driving it on these streets. I don't know, that helps maybe like 50% of students. But I've got to count 3 units up. From this point, 1, 2, 3 boxes or 1, 2, 3 lines. It doesn't matter. That right there is going to be the image of the pre-image red point that I put on the graph. Now, do I need any lines yet? No, I do not. I do not connect this pre-image point with an image point. What I'm going to do is connect all the image points with each other, not pre-image to image. So I'm going to go to the next point. Let's go to this one right here. But again, that's a pre-image point. I've got to move it 2 units to the left. So hopefully these lines are visible enough. But that's 2 units to the left. You can count lines. You can count boxes. 2 units to the left. 3 units up. 1, 2, 3 boxes, or 1, 2, 3 lines. But that is where the image point will be. Now you could connect those two, but I'm going to wait until they're all on the graph before I start connecting stuff. I've got to do it with the next point also. So make this our green pre-image point, and I've got to move this one 2 lines or 2 boxes to the left, and then 1, 2, 3 boxes up. Or if you want to count lines, 1, 2, 3. But that is where the image of the green point will be. One final point. We've done 3. Last one. So let's take this point right here at the bottom, and let's move it 2 to the left. 1, 2 boxes, 1, 2 lines. Doesn't matter. And then 1, 2, 3 boxes or 1, 2, 3 lines. It's going to put us in the same location on the graph, but this blue point that I've just put on is now the image of the blue pre-image point. And now that I have those, I'm ready to draw the lines between the points. And as you see, my lines aren't always so straight, but that's okay. That's all right. That's it. That's all we got to do. But notice, I did not focus on the lines until I got all the points on the graph. That's all you got to do. Now do be careful. You're not going to be connecting points through the shape. So you just go on the outside of the lines, of the points. Don't connect the purple to blue or green to red. Reflections. Reflection is the same thing as mirroring. Some students understand that better. So for those of you that maybe understand mirroring, I don't know if you do or not. But what you're going to do, it's kind of like, I don't know, let's take this trapezoid. It's going to turn it like this. See, now, if this trapezoid somehow was able to look into a mirror, then it would be, I don't know, some kind of straight line right here, like this. Well, if it was to look into this mirror, and let's say there's our pre-image, then the image would be facing the other way. Let's see if I can do this with some technology. All right, that's not bad. But we can see, it doesn't even matter which one's the pre-image or the image, but it's just flipped the shape, okay? But what we have here is the mirror, which we would call the mirroring line, or mathematically, it's called the line of reflection. So if you want to show off to your friends how nerdy you are, you'd use line of reflection. But what we may notice, if my drawing was a little bit better, is that the distance between the points and the reflection lines is the same. Meaning, if you were to take this point right here on, we call that the pre-image, it is to the right of the reflection line. The image is the same distance, but in the opposite direction like this. And that would be true for all 4 points on this trapezoid that's looking at itself in the mirror. So that's what we're going to do, and that's all we got to find. So one way to do this, sometimes what they'll do is they'll give you 2 shapes like this, and they'll say, well, where is the line of reflection? What you can do is you can connect 2 of the points. So let's say like this point and this point right here. What you will do is you will connect these with the line like this, and the point right in the middle is where the line of reflection is. which would be the same for this one. Now, you may have to do this with two lines, but once you do, all you got to do is connect all you got to do is connect the points with a line, just like this, okay? So, mirroring is good. We have some kind of mirroring line, which is called the line of reflection. Usually, the only types of mirroring that we have are usually with a mirroring line that is vertical like this one, but sometimes you'll see that we will reflect over horizontal lines as well. Sometimes it would be like the y-axis here, or maybe the x-axis right here. It doesn't really matter, but it's possible that they may have you reflect over these diagonal lines. This one or this one. Now, we don't have to actually write the equation, meaning we're not asking you to find the slope and y-intercept on these. But just know if it's diagonal like this, that it's going to be a positive x, y equals positive x line, because the slope is positive. It goes up from left to right. And then this one is negative x because the slope is negative going down from left to right. Keep in mind also, because this will happen, and what they're going to do is they're going to say, here's a y-axis, and here's an x-axis, but what they're going to want you to do is to reflect over this line right here. Okay? Now, if you wanted to find the equation of that line, which we would, or we will on the assignment, since it's going through the y-axis, it's going to be y equals whatever that number is. But the same is true for vertical lines, which we could see, something like this. Something like this one. But again, it's going through the x-axis right here. So these vertical lines, just as a review, is going to be like an x equals equation. Not all of them are going to be horizontal or vertical, so again, expect something like these two as well. One of the main reasons we're saying this, so don't worry about the lines. If we're to go back here, if this figure goes over the line of reflection, sometimes the lines tend to confuse students. Don't worry about the lines, just focus on the points. So again, if this point, if the shape was somewhere in this area, something like this, then you'd still reflect it the same way. But don't worry about the lines until you get everything reflected. Once you reflect everything, then you can connect the points to make new lines for the image. Here at the bottom, it says, reflecting does not change the size, which means, just like translations were, or moving the figure, reflections will maintain congruency. So, not changing the size means that all I did is I took this shape, I copied and pasted it, and then I just flipped it in order to get this new shape. But it's exactly the same size, you have exactly the same angles and side lengths. It's exactly the same trapezoid, so that means that we have congruence. So let's take a look. Is this a reflection? Yes, it is. All they've done is they've taken one of the two. We don't know which one's the pre-image or the image. I would assume A is the pre-image, just because A is alphabetically before B, whatever. And then B would be the image. So yes, this is a reflection. So thank you for that. Is it a reflection? Yes. If so, what line is it being reflected over? Well, I can see it's going from a upward position to a downward position, which means that the line of reflection has to be one of these horizontal lines like this. So again, we can figure this out simply by taking points on the shape, two shapes, the pre-image and the image. I'll use these two right here. And again, it doesn't matter which one we say is the image or pre-image, but what I do notice is that I can connect these with the line here. And then, all I got to do is figure out where halfway between that is. So, 1, 2, 3, 4, 5, 6, 7, 8. It's 8 units between the 2 points. Halfway would be 4 units, which would put us on this line right here. So that line, once again, we can follow this line back to the y-axis. It leads back to the y-axis. And horizontal lines, hopefully we remember that. But that is where y on the y-axis is 0. So that is the equation. That is the line that it's being reflected over. Y equals 0. And then, yes, it is a reflection. Now to further demonstrate this though, because you guys are having so much fun doing it. So we have this line of reflection. If you were to connect all the points with these vertical lines like this, and this one, and this one, and these, or even these, then you would notice that the line of reflection is right in the middle of all of these. So I connected the point there that I have in green, but it would have worked for all the points. The line of reflection is always going to be right directly in the middle of between a pre-image point and an image point. So think about it like this. Let's say that the halfway point was right here. Okay, then I would have to follow this line to my y-axis, and then I would see that it's 1. If I see that they're flipped diagonally like this, then I would expect this line, which would be y equals x. If I see them flipped this way, then it would be over this line, which is y equals negative x. We'll see something like that. So is this a reflection? If so, what line is it being reflected over? Okay. So this one is definitely not a vertical or horizontal line. It's some kind of diagonal, which means it should be some kind of y equals x equation line, or it should be y equals negative x. So let's see if we can figure this out. So I'm going to take the points. I'm going to take corresponding points between the image and pre-image, and we don't know which is which. We'll start with these two. They're fairly close together. But I'm going to also use these two down here. Okay? So between the green points, we would have this line. And between the orange ones, we'd have this line. So let's see. It may be kind of hard to see where halfway is, but between the green line is just kind of between one corner of a square in the grid, which means the halfway point is going to be just right in the middle, right here. Okay, and then the orange one, the orange line. So this is going diagonally through 1, 2, 3 boxes. So I'd have to count 1.5, which would be about right there. Now, you may not even need this because we know it's a diagonal line, and you can see that it's slanted this way down from left to right. So some of you may have gotten the answer already, but since some of you may not have, that's okay too. We can see if I connect these points. Not that I did that so great, but I get this line. This is my line of reflection right here, the blue line. So this line of reflection, it definitely is a reflection, by the way. So we can put yes there on the first question. Yes. But what is this line of reflection? Well, that is the equation. Y equals, it's slanted down from left to right. So it's going to be a y equals negative x reflection right there. Okay? And again, let's say that you wanted to go back and for some reason, because you like drawing all these lines, you can do it with any of the corresponding points. Doesn't matter which ones you choose. The line of reflection is always halfway between a reflected pre-image point and a reflected image point. So that last example, it was saying you have figures that are already reflected. You have to determine if they're reflected as well. But they were reflected, and then we got to figure out where that line of reflection is. Nice. But now they're actually going to say you got to reflect a figure. So all we got to do is find the mirroring line, which the nice thing about this assignment is they're going to give us the mirroring line. Usually in the past they would just give us an equation for a mirroring line, then we would do it. We'll still look at the equations of the mirroring line just so you guys are prepared for the future, but today they're going to give those to us. Then we got to figure out how far the points on the pre-image are away from the mirroring line, the line of reflection. And then the reflected points are on the other side of the mirroring line in the opposite direction. That is all. Okay? And it should be directly in the opposite direction. And then connect the points to make the same mirror. That's this fourth part right here is after we get all the points mirrored over some kind of mirroring line or line of reflection. Let's go through what we were just talking about right there. So they've given us this mirroring line. It says reflect the figure over y equals 1. Well, how do we know this y equals 1? Because it's a horizontal line going through the y-axis at 1. That means that this line of reflection is at y equals 1. Boom. And that would be the equation for the line. They didn't ask for that, but I still did it. So I'm going to start reflecting points, and we got 4 points on this figure. And this is definitely a pre-image because this is what we're starting with, and then we've got to reflect this over a line, so it's a pre-image. So I would say, look, between that line of reflection, the blue line, and the red point right there, it is down below the line of reflection. How far? 1, 2, 3, 4. So it's, let me say 4 down. Which means its reflected image point has to be 4 up. So from this line of reflection right here, I'm going to go 4 up from where it is, where the line is already connecting with the line of reflection. I go 1, 2, 3, 4. I'm counting boxes, but you can count lines. And that is where the image point will be. Because I went 4 up. Again, 4 down, 4 up. That is from the line of reflection. Now that's one point. We got 3 more to go. And since we like doing this so much, hey, we're having so much fun. So on this one, again, from the line of reflection, I see that this is down. How far down? 1, 2, 3, 4, 5, 6. I counted boxes. You can count lines. So I went down 6. So I've got to go up 1, 2, 3, 4, 5, 6. That's going to be up 6, which would give me this line. From the line of reflection. That means this is where the point goes, the image point of that point, the purple point on the pre-image. Okay, well, we're doing pretty good. Let's go to the next point. I'm just going to go clockwise through this. But I'm going to start here at this point, which is down. How far down? 1, 2, 3, 4, 5, 6, 7. So I've got to go 7 up from the line of reflection. 1, 2, 3, 4, 5, 6, 7. So that's where my point will be. Again, that's 7 up from the line of reflection. The last point that we have, I'll do in green. So it's definitely below the y-axis. How far below? 1, 2, 3, 4, 5, 6, 7, 8. So I've got to go up 1, 2, 3, 4, 5, 6, 7, 8. That means my reflected point should be here. So I can do with the line. Now that I have all 4 points reflected over the line of reflection, now all I got to do is connect these points to show the reflected image of the pre-image. Now be careful. What's going to happen is sometimes they're going to flip this over the line of reflection. Like I've said before, though I didn't say it on this one, don't worry about the lines. Don't worry about where they are. Just see where the points are, the corners are, in relationship to the line of reflection. That's all you got to do. You don't have to worry about this one slanted down, this one slanted up, slanted down kind of stuff. Don't worry about that. Just get the points on the graph and then connect the points. But again, on this one, like you wouldn't want to connect green and purple or blue and red right there because you do not want to connect lines through the shape. Okay, reflect this figure over the line x equals 5. And again, they've already given us the line of reflection here, x equals 5. How do we know that? Because the line goes through the x-axis at 5, and it's vertical. So technically the slope is infinite, but this line has an equation, x equals 5. All right, now it's vertical, but again, we look at each point, all 3 points on this triangle. Don't worry about the lines, ignore the lines, because sometimes they will go over the line of reflection, which is okay. But we just got to focus on the points and determine how far away they are from the line of reflection. So for example, I'll start here on this red point. So from the line of reflection directly, this is 1, 2 units to the right. So it's 2 to the right. To reflect it from the line of reflection, I would have to go 1, 2 units to the left, and that puts me right there. So I have the pre-image point in red and its image in red as well. I'm going to continue clockwise around this, so I'm going to go to the top point there. How far away is this from the line of reflection? 1, 2, 3, 4. 4 units to the right, which means its reflected point has to be 1, 2, 3, 4 units to the left, putting the image point right here. And then finally, this bottom point right here. I count this 1, 2, 3 units to the right, which means its reflection has to be 1, 2, 3 units to the left, which would be right here. Now again, that's all 3 points. Be careful, we're not concerned about the lines or if the lines go over the line of reflection. Just I mean, even if you could erase the lines and focus on the points, that might be better for you. But now that I have this, I can connect the points and I have a reflected image. Now, I don't know if you guys noticed this on the last problem, but when we reflect points over a line of reflection, they always must make right angles with the line of reflection and the line that you're connecting the point with and the line of reflection, like this. They will always create right angles. That's not important for us necessarily today, but it will be probably in 10th grade. What is the image of negative 5,3 after a reflection over the x-axis? Good question. Now, it may be helpful to see how this is going to work. So we have an x-axis and a y-axis there. Negative 5,3, the ordered pair, would be somewhere around here. Now, if we're reflecting this over the x-axis is the horizontal axis here. So that is going to be our line of reflection. And we can see then that 5,3 would be up from the line of reflection, so it would have to go down the same way, which would give us a image point somewhere right here, something like this. I know that's not perfect, but my drawings are, hopefully they demonstrated enough. So what's going to happen here? Well, what you may notice about this graph is that the x value on the x-axis does not change for the ordered pair. So in my image ordered pair, I would keep the x the same as negative 5. Then what happened to the y value? Well, it used to be up from the x-axis, but now it is down. So while it used to be 3, now after its reflection, it would be negative 3. And this would represent the image point of the pre-image point, negative 5,3. All right, so this kind of generates a rule for us. If you're reflecting over an x-axis, you're going to keep the value the same, but you're going to change the sign of your y value. On the other hand, if you were to reflect over the y-axis, what you're going to do is keep the y value the same, but you're going to change the sign of the x value. That's it. And you may see some of those on the assignment too, but this is the ordered pair we're looking for. All right, I know some of you guys are sad to see this lesson end. It was super exciting and full of excitement and fun. But it's over, so hopefully we feel pretty good about translating and reflecting.